All right, we're back. And so what we're going to do now is some extra examples. So we've basically covered all the new material now. And what we're just going to do now is just run through some more examples of kind of each type of problem we've seen up to this point. So what we're supposed to do is find the x-intercepts and the multiplicity. All right, so that means we have to factor. So when we do that, what we have to do is we're going to factor out an x squared because there's an x squared in each term. And what's left over? Well, there's an x to the fourth minus the 3x squared minus 4. Okay. Now, can we factor that? Well, yeah, we can. And so what we have to do is we think, okay, well, that's x squared times, well, this is going to probably be x squared times x squared. And 4 is probably, to get a 3, we have to use a 1 and a 4. And the large one has to be negative, and the smaller one positive. Okay. Now, that can be factored. That's the difference of squares. This is the sum of squares, which doesn't do anything for us. So that's x squared times x squared plus 1 times, well, this is the difference of squares, so that's x plus 2, x minus 2. Okay. Now, that is as most as we can factor it. So now what do? Well, we look and set each one of those equal to 0, and we see what its factors are. So this one, we get x equals 0, so we're going to get the point 0, 0, and let's put this as the multiplicity column. And so what is its multiplicity? Well, its multiplicity is 2. Now we can set this equal to 0, and we get x equals a negative 2, so we get negative 2 comma 0, and its multiplicity is just a 1. We can set x minus 2 equal to 0. We get x equals 2. So 2 comma 0 is our intercept, and its multiplicity is also 1. Now, what do we do about that x squared plus 1? Well, if we set that equal to 0, we get x squared equals a negative 1, and we're going to get an imaginary number, and we're not going to worry about an imaginary number. So these are our only actual x intercepts that we're going to worry about. Okay, now what is the X intercepts multiplicity? So we've got it. Okay, and again, because we get an imaginary number there, we're just going to stop at only the real numbers, because we're going to plot this on a real number graph. We're not going to plot it on another kind. What about the next one? Well, it looks like, again, we can factor out something. Well, here, each one of them has a 3 we can factor out. And each one of them has an x squared we can factor out. So if we pull out a 3x squared here, we have x squared. And then we have plus, and here we can pull out a 2x is left. And here, well, we have plus 1. Okay, well, 3x squared. Now, can we factor that? Well, yeah, that's x plus 1 times x plus 1, or just x plus 1 squared. Okay. Now, so doing the same thing here, we can get x equals 0, so we get 0, 0. And again, if we put our multiplicity over on this side, the multiplicity of that is going to be 2. Now we set this equal to 0, we get x equals a negative 1, so negative 1, 0, and its multiplicity is also 2. Okay, and that's all we have. So we found the intercepts, and we found the multiplicity. What about the next one? All right, so we're supposed to write a formula for the polynomial of least degree, identify the zeros and the multiplicity. So last time we had one that looked like this. It was an M instead of a W. So it's going to be probably something similar. We know it's going to be an even function, and it's going up, and so k is greater than 0. So now let's write our zeros. So it looks like a negative 4, 0. We have a negative 2, 0. And we have a 3, 0. Now, if we put our multiplicities in this column, at negative 4, 0, well, that's coming through. It looks pretty linear, so I'm going to call that a 1. I'm going to call that one a 1. And this one, the least degree, that's an even number because it bounces off. And so I would say that's going to give me a 2. Okay. Now, 2 plus 1 plus 1 is 4. That's even, and so that makes sense. And so now we also have a y-intercept. So these are x-intercepts, and our y-intercept is equal to, well, it looks like 0, 3. Okay. Now we have everything we need to start writing our function. So f of x equals a times, and then we have x plus 4, x plus 2, x minus 3. Now the multiplicity, 1, 1. Oop, that one's 2. So we need to have that on there. Now we solve by plugging in this into here. And so we have 3 equals a times. Now if we plug in our 0 here, we get 4 times 2 times. Now we have a negative 3 squared. So 4 times 2 is 8 times negative 3 squared. Negative 3 times negative 3 is going to be positive 9. So 9 times 8. So that's 3 equals a times what? 72. Now we're going to divide by 72. And so a equals 1 over 24. So it's a positive. That's what we said it had to be. We have an even number, so that looks good. So our final function is going to be as follows. F of x equals 1 over 24 times x plus 4 times x plus 2 times x minus 3, the quantity squared. So it's even, and we have a positive k. Okay. What about this one? Okay, so we're going to do the same thing. Now this one, let's look at our end behavior. Well, it goes up and like that, and so it looks like it's going to be an odd function. And because it's this way, it looks like k is going to be greater than 0. All right, so that is going to be my end behavior and my k values. So what are my X intercepts and what is their multiplicity? Well, here we have one at negative 3, 0. And it looks like it's going straight through. My multiplicity has to be 1. Now I have one at negative 2, 0. It's going straight through, so my multiplicity is 1. Now here's a y-intercept, so let's go ahead and write that down while we're going across the screen. And so that's going to be a 0, negative 1. And then I've got one here at 1, 0. And because it doesn't have a straight and it doesn't bounce, that means it's going to be odd. And it's going to be the least multiplicity of odd one to be 3. Okay, so that's going to be the key here because it says of least degree. I could say that was a 5 or a 7, but we want the one that's a least degree. All right, now do I have everything I need? I think so. So I can say f of x equals a times, now if we make that positive, it's x plus 3, then x plus 2, x minus 1, and this one is cubed. Okay. Now I plug in this, and I get a negative 1 equals a times 3 times 2 times a negative 1 cubed. Okay. Well, negative 1 cubed is just going to be negative 1 times 3 times 2. Well, so a negative 1 equals, here it's going to be a times a negative 6. So divide by negative 6. And so a equals 1/6. All right, so it's positive. We said it had to be positive, so we came out good there. And we have 1, 2, and then plus 3 is going to be 5. So the degree is 5. That's odd, so that's good. So I think we have our function figured out. It's going to be equal to 1/6 times x plus 3, x plus 2, x minus 1 cubed. Okay. And so that would be my function in the least degree, and it fits my odd function as well as k greater than 0. All right, let's stop there and we'll come back for more.